Hey everyone, so in this video we're going to cover a very important topic related to matrices, which is matrix multiplication. A matrix multiplication is something that's exceptionally important when you start doing slightly higher level maths. Has lots of applications, right, in all kinds of problems. And it's also a topic that people sometimes find a bit difficult. So hopefully by the end of this video you really understand matrix multiplication. Now if you're not familiar with certain basic matrix terms like element of a matrix, types of matrices and so on, please check out some of our other videos, and that should really help you get the basics that you need to watch this. But I believe you should be able to follow this fairly easily. So let's just dive straight into it. Let's take two matrices. You have a matrix here A. I generally like to call the first matrix A. It's a 2 by 3 matrix. You have a second matrix B. It's a 3 by 2 matrix, and we want to find the product C. We also want to know what the order of that is going to be. So just to get things started, not all matrices can be multiplied with each other. Right? Just keep that in mind, and as we do this case and a few other cases, you will really understand why that is the case. So to multiply a matrix, to get the elements of C, what do you do? Let's start by trying to get the first element of C. So to get the first element of C, C11, what you have to do is take the first row of A and multiply each of those elements with the corresponding elements of the first column of B. So how do you know it's first row and first column? Well, you want C11. So the corresponding, to get the, so 1 here, the 1 here is the first, or the first subscript here is the row index. Right, or indicates the element in the first row of C. So that, what you do is take the matrix on the left, the first matrix, which in this case is A. You take the first row of A, and to get the element, the column index is, here in this case is 1. The column index, you take the corresponding column of B. Right. So the row index of this element, take the first row of A. And to get the column index related, take the corresponding column of B. And that's what I've written here. It's the sum of each, and this is a notation that indicates you have to sum over each of the J's. But to get 1, you take all the elements of row 1 of A, and you multiply each element with the corresponding element in the first column of B. Right? Okay. And so the reason you have J and J common here is you have to multiply by the corresponding. So what does that mean? Well, simple, right? To get this first element, take 2 multiplied by 1. So A11 times B11. So the J is the second index. So that 1 and 1, right? Plus A12 times B21. So again 1 and 1. But it's 2 and 2. So it's A1, 2 and B21. And then the third, you take the third element of this and you multiply it by this. So that's A13 times B31. Now you can see very clearly that, for this, for the A, you want C1. So it's A1 here, A1 here and A1 here. You want the second, the column index is 1. So you have B1 here, B1 here and B1 here. The column index of B is always 1, is 1 in this case, and the row index of A is 1, and the other elements, right, the column index of A and the row index of B are the same. So it's 1 1, 2 2, 3 3. Let's look at the next element, and by the time I get through this entire matrix, I'm pretty sure you will understand it very clearly, right? So the answer to that is that. Okay. So now you want C12, right? So C12, what do you do? So the row index of C that you want is 1. So you take the first row of A. The column index of C that you want is 2. So you take the second column of B and you multiply the corresponding elements and you add them. So what happens there? You take A11 times B12. That's this. A12 times B22 and A13 times B32. So again, look at this, it's 1 2. So row index is 1, so the row index of all the A elements is 1. A1 here, A1 here and A1 here. The column index is 2, so it's B2 here. The column index of the B element is 2, the column index of the B element is 2, the column index of the B element is 2. And in between, This is 1, this is 2, and this is 3. Right? That's the easy way to look at this. So that's very simple. What about the third element? Now I'm pretty sure you will guess this. So you want C21, right? So what do you do with C21? Well, you take the second row of A because you want C2. Take the first column of B and you multiply the corresponding elements. So you get that here, right? And I'm just go through this and see if the same logic I explained for the last two cases makes sense. And to get the fourth term, C22, second row of A and second column of B, because it's 2, 2. So the row index you take from A and the column index you take from B, right? And it's the row of A and the column of B. So C22 is that, it's A21 into B12, A22 into B22, A23 into B32. So again, here its row index of C is 2. So row is always A, the first matrix. So the row index of A is 2 for all the 3 elements. The column index is 2. The column index is the columns of B. So B has to be, the column index of B has to be 2. And then you're multiplying the corresponding elements. So A21 and B12. The column of A here is 1 and the row of B is 1. The column of A is 2, the row of B is 2, and the column of A is 3, the row of B is 3. So hopefully that really explains, and that's it, that's matrix multiplication, right? So now the question is, what's the order of the matrix? So apply the same principle, right? Apply the same rule, right? To get the order of that matrix, take the row of A and the column of B, and that's the order of this. So A has 2 rows, so 2, and A and B has 2 columns, so 2. So it becomes a 2 by 2 matrix. So what you should see here, it's interesting, which is different from matrix addition, is you've taken a 2 by 3 matrix and a 3 by 2 matrix, and you've ended up with a 2 by 2 matrix, right? It's a different size to the other 2 matrices, right? Because you're taking the column size of this, or the number of columns in A, and the number of rows in B, and that's what you get. So to compute the order, again, 2. Now the other thing you should note here, right, the other thing you need to note here is, what about this? So you see that for matrix multiplication to work, if you remember what I just told you a second ago, you need to multiply, for example, to get C11, the first row with the first column, the first row of A with the first column of B. But you take the first element here, you multiply it by the first element there. You take the second element here, you multiply it by the second element there. You take the third element here, you multiply it by the third element. So what happens if you have an extra element here, you have 4 columns here, then you don't have a corresponding element here to multiply with. So it's important that the order of C is the number of rows in A and the number of columns in B. But it's also important that the other 2 indices, right, the number of columns in A and the number of rows in B are the same. Otherwise matrix multiplication is not defined, right? So that's equally important, and if that's not the case, it's not defined. If you take a general case, and I'm using the same matrix as example, but to get the elements Cik, multiply the elements of row I of A with the elements of column K of B. Okay, why do I use I and K instead of I and J? Well, you write A as Aij and the size is M cross N, or the order is M cross N. Now you know by now that the number of columns of A has to be equal to the number of rows of B. Also you know that this index here of the element which you see here, Aij, Bj, 1, right? So this index here has to be equal to this index there. So to make it simple for people to understand, generally what's done is J is used as the common index here. So Aij and Bjk, the column index of A and the row index of B are generally denoted as J. And so the column index of B is now K, right? So if you multiply a matrix Aij cross Bjk, then assuming that the size is correct, it's n here and n here, the first one first matrix, in this case A, has n columns and B has the same number of n rows, then C, which is the product, is defined. The C has m by L. It has m rows, it has the same number of rows as A and the same number of columns as B. And the elements are denoted by CIK. And what is CIK? Well, just this definition here, it's a general version of that. You sum over J, Aij times Bjk, right? So in this case, for example, Aij times Bjk, for this particular case, C11 would be A11 times B11, A12 times B21, and A13 times B31. We've already seen this, right? So that would be C11, right? So just go back to the previous, matrix multiplication example again, and just note this expression down on a piece of paper and just see if you can understand why this expression is the case. This expression I've written here, the general expression, is the case for each of those multiplications I've shown you. And what you see here, this small description on the right, is what it is for C11. So that should help you make sense of the idea. And to get the order, right, it's very simple: m by n, n by L. So the first thing that's important is the number of columns of A is equal to the number of rows of B. And if that's not the case, matrix multiplication is not defined. But assuming that is the case, then the number of rows of C is equal to the number of rows of A, and the number of columns of C is equal to the number of columns of B. So the order of C is M cross L. Okay. So let's do another example of matrix multiplication. Now, if you notice, what I've done here is I've taken the same A and B, but I'm multiplying it in the opposite order. So I'm multiplying B by A. Now what I'd like you to do is take a piece of paper, just pause this video and just see if you can do this, right? Just see if you can do this, right? Okay. So the first thing you look at is the order. Now again, we know that here you see the column index of A is 2 and the column index of B, is 2. The row index of A is 2. So clearly these two can be multiplied, because if you multiply this, the first row here and the first column here, it's 1 into 2 plus 5 into 7. So it can be multiplied, we've proved that. So we also know that the order of C is 3 by 3. Simple. So I'm just going to show you the answer first, right? So you can just check quickly what you get. So this is what you get. Now because it's got 3 rows and B has got 3 rows and A has got 3 columns, what you end up with is a 3 by 3 matrix. And that's the answer. So if you want to check your steps, here goes, right? 1, 5 into 2, 7 is the first element. 1 into 2 plus, so 1 into 2 plus 5 into 7. That's the second step. Now we've got the first row here, third column here. Then you go and you want to get the elements of the second row here. So you multiply the second row of this with the first column here, then with the second column, then with the third column of A. And then to get the third row of C, you take the third row of B, multiply it with the first column of A, then the second column of A, and the third column of A. Simple, right? Okay. So hopefully that's, you've got the same answer. And if not, just pause the video, go ahead and try it again and look at the steps again, right? Simple. But hopefully most of you have already observed one very interesting thing, which is when you take AB and you multiply it, you get a 2 by 2 matrix, which is this. You change the order and multiply BA, you get a 3 by 3 matrix, right? Which is different from matrix addition, right? If you change the order of matrices when you add them, doesn't matter, you get the same solution. But with matrix multiplication, it does matter. Now what's also equally important is, in this particular case, it's very important to note that it was possible to switch the order because it's 2 by 3 and 3 by 2. So if you write it as AB, then the number of columns of A is 3, the number of rows of B is 3, so you can still find the order. If you flip it and you make it BA, then again the number of columns of B is 2, the number of rows of A is 2, and so you can do this. What if B was a 5 by 2 matrix, right? If it was a 5 by 2 matrix, then AB is not defined, right? But BA would be defined, because if it's a 5 by 2 and a 2 by 3, 2 and 2 would match, so you can get a 5 by 3 matrix. But multiplying AB would not work, right? In case assuming B was a 5 by 2 matrix. And you'll see a few more examples like this if you do the quick test, right, where you try and understand or a few more cases of this particular. And so the property that AB is not equal to BA, assuming both AB and BA are defined, is written as the matrix multiplication is not commutative. Okay. So let's try an example, right? So this is a 2 by 2 matrix. Try multiplying it. So let's go step by step. To get the first element of C, you'd multiply 3 into 1 plus 0 into 2, right? Okay. So that's defined. What's the next element? Well, next is you want the second here. The second, the element here, you want element 1, 2 of C. So take the first row away, multiply it by the second column of B, and what do you get? You get 3, 0 and 2, 1, and you get that element. Now what do you want? You want the element 2, 1. So second row of A, first column of B, you get that. Second row of A, second column of B, you get that. And hopefully, and I didn't say this specifically, but hopefully before you did this, you checked that this matrix multiplication is defined, right? It's a 2 by 2 matrix times a 2 by 2 matrix. So the element here, which means the number of columns of A is equal to the number of rows of B. So this multiplication is defined. And at the end, you end up with a 2 by 2 matrix. Is that correct? Yes, because the number of rows of A is 2 and the number of columns of B is 2. So 2 by 2 matrix. So that's the order. Superb. What about this case? So start multiplying. And what do you see? See that this multiplication is not defined, right? Because you can multiply 2 by 1, you can multiply 3 by minus 1, what happens to 8? You can't multiply it, right? So I'm pretty sure most of you would have observed that even before doing this step, and I did this just to explain or show to you why, this is important. But if you observe, you see here it's a 2 by 3 and a 2 by 2. So this is great, number of rows of A, number of columns of B, great. But the number of columns of A here is 3, the number of rows of B is 2. So matrix multiplication in this case is not defined. So when the number of columns of the first matrix is not equal to the number of rows of the second matrix, matrix multiplication is not defined. Okay, so that summarizes, or that should explain to you what matrix multiplication is. And we've gone through 3 examples here. We've also shown you the property that matrix multiplication is not commutative. We've also explained to you how it cannot be defined. Matrix multiplication might not be defined in certain cases. So now, to get a little more practice, please go to TeachYaar.com and take a quick test. It's a free quick test, and I've dropped an element, a screenshot of that here. So there are a few more questions there that you can try out, and when you do that with practice, you will really understand what matrix multiplication is all about. And once you do it a few times, it becomes very, very simple, and that will really help you with matrix algebra. So to take the test, just scan the QR code on your mobile device, or you can go to this link that you see here, and we've dropped this link in the comment section and also in the description section. So just go ahead and click on the link and you can go and take the test. And please subscribe to the TeachYaar YouTube channel.